Welcome to qnawire.
So in this problem, we're applying a magnetic field, which we'll call B naught. So we're applying a magnetic field B naught to a piece of metal, and we're looking at the induced magnetization, which we'll call just B. So we get a bunch of data points of the applied field we give this piece of metal, and then its magnetization. And from this, we want to plot the magnetic permeability, so mu, of the piece of metal. So mu is a function of the applied field B naught. So to do this, we know that the applied magnetic field should just be mu naught times Ni, since this is a solenoid. And then the induced field will just be the actual permeability for the piece of metal times Ni. So if we want to find mu here, we can just take the ratio of these two things. So we could do B divided by B naught, and that should equal mu Ni over mu naught Ni. And that, of course, is just mu over mu naught. So then we can say that mu, so the permeability specifically for this piece of metal, is just mu naught times B over B naught. So it's going to vary depending on the magnetic field that's applied. So we apply a given magnetic field, we get a given response. So we apply a magnetic field B naught, we get a given response B, and then from that ratio we can determine what the permeability of the object is. So we're asked to plot this, and so I've done that, and I've plotted it just in terms of the quantity mu naught, so I'm not giving actual numerical values. They're all multiples of mu naught. I think that's just a little bit easier to look at. So we get a response like this. So mostly we have a very small response, even at very high applied fields, but there's a very strong spike at lower values, which we can't see too well here. So then I've zoomed in on the plot now over here, and we can see a little bit better the behavior, that there seems to be this strong response right at around 2 or so times 10 to the minus 4 Teslas. So there's some sort of resonance effect happening here, where we get a much higher induced magnetic field in the object, meaning we have a much higher magnetic permeability there. So we can see there's this big spike here, then it kind of trickles off and then pretty much stays constant at that value for a very long time, it seems like.